state whether the following are true or false and justify your answer. You have to tell whether these statements are true or false. Now here the given question, the value of tan A is always less than 1. Suppose let us consider a triangle, right angled at B. I take this is ABC is a right angled triangle. So this is angle A. It's an acute angle. So with reference to this acute angle, we can write tan A can be written as opposite side BC by AB. So now tan A value is always less than 1. Less than 1 means the numerator must be less than always denominator. Always less than the denominator. Then only it is possible. Sometimes, so these two can become equal also. Sometimes BC may be greater than, see look at this, if I take this is 3, this is 4 and this is 5. This is a Pythagorean triplet. If this length is 3 units and this is 4, what happens? 4 by 3. So it is greater than 1. It is greater than 1. So therefore, the above statement, it is false. So you cannot accept this one. Sometimes it will be greater than 1 also. In this particular example, you can see tan A, it is opposite side by adjacent side, it is 4 by 3, it is greater than 1. So in all cases it is not true. Sometimes it is less than. Instead of this 4, if I take 3 here 4, then it is less than 1. But in this situation, it is greater than 1. So this statement is false. So the given statement is false. Sometimes these two may be equal also. Okay, isosceles right triangle, if I take, these two are equal. Sometimes it will be equal to 1. Sometimes it is greater than 1. Sometimes it is less than 1. So therefore the given statement is false. Now come to the second one. Secant A is 12 by 5 for some value of A. Same thing let us take. So right angle triangle, you can take a right angle triangle ABC. You can take ABC is a right angle triangle in which A is acute angle. This we will take it as an acute angle. Secant A. What is the ratio of secant A? Secant hypotenuse divided by adjacent side. So it is 12 by 5. So hypotenuse here, this is AC. AC by adjacent side here AB. It is 12 by 5. Okay. The ratio here 12 by 5. Look at this. It is possible. Hypotenuse is greater. Hypotenuse is greater than this adjacent side. So it is possible. 12 by 5 is possible because the hypotenuse is the longest. Had it been reversed, 5 by 12 means you cannot accept that one. Instead of this, if I give 5 by 12, so that means hypotenuse cannot be less than the other two sides. If I write this 5 by 12, so this will become hypotenuse. Hypotenuse is smaller than the other side. So this is false. Hypotenuse should be the longest side. So even if you find out the other side, BC, using Pythagoras Theorem, so you will get the smaller than this 12 only. Okay, smaller than this 12, this is possible. So therefore this statement is true. You can write this as it is true. So it is possible. The second statement is possible. So hypotenuse AC is hypotenuse. Hypotenuse AC is greater than, so adjacent side AB. Adjacent side AB. This is possible in a triangle. So therefore secant A 12 by 5 for some triangle, some value of angle A, it is true only. So now let us go to the third one. Cos A is the abbreviation used for cosecant of angle A. Is it true? False. It is false. So you can write this as a false statement. It is a false. What is the reason? Cos A is an abbreviation of cosine. It is an abbreviation of cosine of angle A. Cosine of angle A, not cosecant of angle A. So it is an abbreviation of cosine of angle A. So therefore this statement is false. So now let us go to the fourth one. Cot A is the product of cot and A, like that they are given. Again it is false. The reason is cot A is nothing but cot A represents, it is a cotangent of angle A. It is not the product of, it is not the product, it is a ratio. It is not the product of cot and A. So it is a ratio between two sides. It is a cotangent of angle A. So therefore the given statement is false. So now the last one, fifth one, sin theta is 4/3 for some angle theta. Let us draw one triangle. I can write this is ABC. So I will take this angle theta. This is angle theta. Now sin theta with reference to this acute angle. What is sin theta? Sin theta is given 4/3. What is the ratio? Opposite side by hypotenuse. So it is nothing but BC by AC is equal to 4/3. So here BC here hypotenuse is So BC is opposite side. AC is hypotenuse. This is hypotenuse. This is opposite side. Now look at this. Hypotenuse is smaller. So here what you are getting? So hypotenuse AC is smaller than BC because it is 4/3. AC is smaller than BC. So it is impossible. Because hypotenuse AC must be greater or longer. Must be longer than the opposite side BC. This must be longer. AC must be longer. Look at this. AC here 3 units. BC here 4 units or 4K. Some ratio if you multiply by a number, it is 4K units. It is 3K units. So hypotenuse here looking smaller. It is coming smaller. Therefore it is impossible. So this statement is also false. You cannot accept this one. So it is impossible. This ratio is impossible because this is hypotenuse, opposite side by hypotenuse. Hypotenuse should never be smaller. It should be always a longer side. So therefore this statement is false. Now after this, so let us go to another very important topic, trigonometric ratios of some specific angles. You can write trigonometric ratios of. See, as I said, we are going to learn only these 3 angles and it is removed from the syllabus now. We can discuss that also now. Now first let us take the trigonometric ratios of 45 degree. Trigonometric ratios of 45 degree angle. We will take first 45 degree. So now you can consider one triangle which is isosceles right triangle. So let us take a triangle ABC. ABC is a right angle triangle. Right angle at B. Let ABC be a right triangle. Be a right triangle. Right angle at B. And another condition. AB should be equal to BC. So let us take both are equal to some A units. So I am going to take this is A and this is also A units. Now you can find out the hypotenuse here. Since these two sides are equal, A and A, you can apply Pythagoras Theorem. AC square will be equal to, you write here AB square plus BC square. So AC square will be equal to AB value we have taken as A. So it is A square, then this is also A square. Both are A units we have taken. Now AC square will be equal to 2 times A square. So AC will be equal to root of 2A square. A will come outside. AC is equal to A root 2. So this is the value of AC. A root 2 units. Now you can write now all the trigonometric ratios. So first one, 1 by 1 we can write first sine 45 degree. What is sine 45 degree? So here, since these two sides are equal, you can write these two angles are also equal, because AB is equal to BC, which implies angle A and angle C are equal. Both will be equal to 45 degree only, because this itself 90 degree, then these two will become 45, 45. Total some angles and property 180 degree should be there. Since these two angles are equal, both will be equal to 45 degree and 45 degree. Now you can take any one, sine 45 degree I want, either you take A or C, since both are equal to 45 degree only. Now let me take with reference to C, sine 45, opposite side by hypotenuse. So you can write A divided opposite side here A, hypotenuse AC is A root 2. A root 2. So A gets cancelled, so you will get 1 by root 2. So what is sine 45? It is 1 by root 2. Next, similarly, let us find out cos 45. So cos 45 is equal to adjacent side here with reference to angle C. Again A, adjacent side A, hypotenuse A by root 2. A by A root 2. So again A cancels, you will get 1 by root 2. So sine 45 also 1 by root 2, cos 45 also 1 by root 2. Let us see tan 45. Tan 45, it is opposite side by adjacent side with reference to this angle C. Opposite side here A, adjacent side also A. So A divided by A, your answer is 1. So you got 3 trigonometric ratios of sine 45 degree. Sine 45 1 by root 2, cos 45 1 by root 2, tan 45 1. Now you know that remaining you can write very easily. So cosec 45 degree. Cosec 45 degree, it is hypotenuse divided by opposite side. Hypotenuse divided by opposite side are reciprocal of this one, it should be root 2. Hypotenuse here A root 2 divided by A gets cancelled, you will get root 2 only, or you take the reciprocal of this one. Then secant 45 degree. Secant 45 degree, it is at hypotenuse by adjacent side. A root 2 by A, you will get root 2 only. It is also the reciprocal of this one. Secant 45 is the reciprocal of cos 45. Cos 45 here 1 by root 2. So take the reciprocal of 1 by root 2, it gives you root 2 only. So the last one, cot 45 degree. Cot 45 degree, it is the reciprocal of 1 or adjacent side by opposite side A by A, adjacent by opposite side A by A, it is also 1 only. So these 3 ratios also we learn. So very easy to remember. You remember this triangle, right angle triangle, which is isosceles right angle triangle. These two sides should be equal. A, B, C. You can write this as 1, 1, root 2. You can write 1, 1, root 2. A, root 2. A root 2. If you divide A, you will get 1, 1, root 2. Looking this, these two are 45 degree, no? So you can say sine 45, 1 by root 2, opposite side by hypotenuse. Cos 45, adjacent side by hypotenuse, 1 by root 2. Tan 45, opposite by adjacent, 1 by 1, it is 1. So cosec 45, hypotenuse by opposite side, root 2 by 1, it is root 2. Secant 45, hypotenuse by adjacent side, root 2 by 1, it is root 2. Cot 45, adjacent by opposite side, 1 by 1. If you remember this diagram, you can write all these ratios very easily. Sin 45, opposite by hypotenuse, 1 by root 2. Cos 45, adjacent by opposite, 1 by root 2. Like that you can remember by looking the diagram. So after this, we will go to the next trigonometric ratio, 30 degree and 60 degree. To find out the trigonometric ratio of 30 degree and 60 degree, we have to take an equilateral triangle here. So first let us take an equilateral triangle ABC. So consider this A, B and C. So here, so let ABC be an equilateral triangle. Equilateral triangle. So that means AB will be equal to BC, it will be equal to CA. We will consider all are equal to A units. So you take this as A units. So this is also A, this is also A. All are equal to A units. Now draw a perpendicular now. Draw AD perpendicular to BC. So draw AD perpendicular to BC now. So you can take this as 90 degree here, this also 90 degree. Now you got two right angle triangles here. So now this total length is A, this is A and this is A. Can you tell me what will be the length of BD? So you know that triangle ABD will be congruent to triangle ACD. So this is, you can prove this by congruency. These two sides are equal. This is a common side. This angle equal. Bisect this one. So you can prove by any method these two triangles are congruent. Once the triangles are congruent, the corresponding parts will be equal. So this is 60 degree and this is 60 degree. You know that this is 60 degree and this is 60 degree because an equilateral triangle. This whole angle is 60 degree. Then this will be a bisector of this angle. Then naturally this will be 30 degree and this is 30 degree. So this is 90 degree. This is 90 degree. So now you got this triangle. Look at this triangle now. This much only. Only you see this triangle now. In this triangle, this is A units. Tell me what about BD? It must be A by 2. This is A by 2. So using this, you have to find out the length of AD. Right angle triangle in triangle ABD. In triangle ABD, we have AB is equal to A, then BD is equal to, it must be A by 2. So find out AD square. So we have AB square is equal to AD square plus BD square by Pythagoras Theorem. AB value substitute here A square. AD value we have to find out, keep as it is. BD square, you know it is A by 2 whole square. So now if you simplify this, AD square will be equal to A square as it is, transfer this to the left side, minus A square by 4. A square by A by 2 whole square means A square by 4. So AD square will be equal to, so 4 is the LCM, 4A square minus A square, that is 3A square by 4. So AD will be equal to, so you know that what is AD? AD will be equal to root of this 3A square by 4. It gives you A square can be taken outside, A, root 3, 4 you can take outside, that is 2. So that means this will be A root 3 by 2. So this is the length AD. So now I will write, divide this entire, only this part I will take once again. So look at this. Or you can take this triangle, either this or this one. So if this is 90 degree, so this is 60 degree, this is 30 degree. Now A by 2, this also A by 2. Okay, so A by 2. This is A into root 3 by 2. And this is A units. So now apply trigonometric ratios now one by one. So I will find out one side 30 degree, another side 60 degree. So let us see sin 60 degree. Sin 60 with reference to this angle. Opposite side by hypotenuse. Opposite side A root 3 by 2 by A. So what happens? A, it is nothing but, so you can simplify this one. A root 3 by 2 into 1 by A. So A cancels, you will get root 3 by 2. 1 by A, you can cancel A and A, you will get root 3 by 2. So this is sin 60 degree is equal to root 3 by 2. Similarly cos 60 degree, adjacent side by hypotenuse. So it is A by 2 by A. So that means if you simplify this one, A by 2 into 1 by A. So A cancels, you will get 1 by 2. Cos 60 degree is 1 by 2. So then tan 60 degree. tan 60 degree, opposite side a root 3 by 2, whole thing divided by a by 2. So simplify this one, root 3 by 2 into, if we make, it is 2 by a. So a cancels, 2 cancels, 2 cancels, you will get only root 3. So what is tan 60? Here it is root 3. We got 3 trigonometric ratios. So very important ratios. We got 3. Sin 60 is root 3 by 2, cos 60 is 1 by 2, tan 60 is root 3. Now remaining easily you can write cosec 60 degree. It is the reciprocal of this one. You can write 2 by root 3. So it is hypotenuse by opposite side. A divided by a into root 3 by 2. Then in 2 will go to the numerator. It becomes 2 by root 3. Secant 60 degree. It is the reciprocal of cos 60 degree. So you will get 1 by 2 means reciprocal will be 2. Then cot 60 degree. It is the reciprocal of tan 60 degree. Root 3 reciprocal of root 3. It is 1 by root 3. So this is the another 3 trigonometric ratios. Now all the trigonometric ratios 60 degree we found out now. Sin 60 root 3 by 2, cos 60 1 by 2, tan 60 root 3, cosec 60 2 by root 3, secant 60 2, cot 60 1 by root 3. So this is related to 60 degree. Now in the same way let us find out the trigonometric ratios of 30 degree. So I will write here sin 30 degree with reference to this angle 30 degree. Opposite side by hypotenuse. So it is a by 2 divided by hypotenuse here a. So what it gives? A by 2 into a by 1 will become 1 by a. Cancels a and a, you will get 1 by 2. Sin 30 is 1 by 2. Then cos 30. Cos 30. Adjacent side here a root 3 by 2, hypotenuse a. So that is a root 3 by 2, whole thing divided by hypotenuse a. If you simplify this, a root 3 by 2 into, this will become 1 by a. So a cancels, you will get root 3 by 2. So cos 30 is root 3 by 2. So it is sin 60 same as cos 30. Cos 60 same as sin 30. Then tan 30. Tan 30 will be equal to, see here with reference to this 30 degree, opposite side here a by 2, opposite side a by 2, but adjacent side a root 3 by 2. Simplify this, a by 2 into, so it will become 2 divided by a root 3. So here 2 cancels, a cancels, you are getting 1 by root 3. See, tan 60 root 3, tan 30 is 1 by root 3. So now the remaining easy to write. They are the reciprocals of, see, cosec 30. Cosec 30 degree, it is reciprocal of sin 30. It is 1 by 2 means it will be 2. So that is nothing but hypotenuse divided by opposite side. Hypotenuse by, with reference to 30 degree. Hypotenuse by opposite. A divided by a by 2. 2 will go to numerator. So therefore it is 2. Then next one is secant 30 degree. Secant 30 degree, it is the reciprocal of this one. 2 by root 3. How you will get this with reference to this one? Adjacent side. A into root 3 by 2 divided by hypotenuse. So a into root 3 by 2 divided by hypotenuse by adjacent side. A divided by a root 3 by 2. 2 will go to numerator, that's why it is like this. Then cot 30 degree. It is the reciprocal of 1 by root 3. So therefore it is root 3. Cot means with reference to this one, adjacent by opposite. A root 3 by 2 divided by a by 2. 2 cancels, a cancels, you will get only root 3 there. So this is the trigonometric ratios of 30 degree. So now I tell you how to remember this one. The same right angle triangle you can write like this. This is 60 degree, or otherwise the other side I can write. See, other triangle also you can write. So this is 60 degree, this is 30 degree. So you know that here this side I have taken. Okay. So now here you can write 1, 2, root 3 you can write. If you remember this 1 to root 3, if you apply this Pythagoras theorem, 1 square plus root 3 square, it is 4 will come, 1 square plus root 3 square, and it is a 2 only. So you can use this one ratio. See, sin 60, opposite by hypotenuse, root 3 by 2, root 3 by 2. Cos 60, adjacent by hypotenuse, 1 by 2. So then tan 60, opposite by adjacent, root 3 by 1. Cosec, hypotenuse by opposite, 2 by root 3. Secant, adjacent, so hypotenuse by adjacent, 2 by 1. Cot 60, adjacent by opposite, 1 by root 3. Come to this 30 degree. Look at this 30 degree, sin 30. Opposite by hypotenuse, 1 by 2. 1 by 2. Then cos 60. Adjacent by hypotenuse, root 3 by 2. Root 3 by 2. Tan 30. Opposite by adjacent side, 1 by root 3. So similarly, cosec 30. Hypotenuse by opposite side. Hypotenuse by opposite side, 2 by 1. Secant 30, hypotenuse by adjacent side, 2 by root 3, 2 by root 3. Cot 30, cot 30 is adjacent by opposite, root 3 by 1, it is root 3. So if you remember this triangle, you can very well write all the 12 trigonometric ratios. See, 1 to root 3, it is nothing related with this one. 1 to root 3, you write here, 1 is the length of this side, 2 is the length of the hypotenuse, this is the root 3. Okay, this is the longest side, root 3 is smaller than 2. 1, 2, root 3. 1, 2, 3. But only root 3. 1, 2, 3. In cyclic order you can remember. So this is 1, 2, 3. Put root 3 here instead of 3. So now use the trigonometric ratios. Sin 60 opposite by hypotenuse, cos 60 1 by 2, tan 60 root 3 by 1, sin 30 1 by 2, cos 30, root 3 by 2, tan 30, 1 by root 3. Same way you can write all the trigonometric ratios by looking the diagram itself. So this is how you can remember 30 degree and 60 degree. Understand the trigonometric ratios of 0 degree and 90 degree now. So let us consider a triangle ABC, right angled at B. Carefully observe this. A, B, C. This is 90 degree. Okay, so you have taken this as an acute angle, you call this as theta. Okay, so now in triangle ABC, angle B is equal to 90 degree, so and angle A is equal to theta. With reference to it's an acute angle, less than 90 degree, this is less than 90 degree, acute angle. So now we want a 0 degree. We want 0 degree, that means this theta should become 0. I want 0 degree means this theta should become 0. So let me draw some diagrams here, 1 or 2 diagrams to make you understand. So this same ABC, I will write here. See, this was the given ABC. So this is theta. Now I am going to reduce this angle. So now if I reduce this angle, this theta is reducing here. Okay, so this C is coming here. Okay, this is A, this is B. Further, again I am going to reduce the same angle. This is a given triangle C, A, B. So instead of this, again further I will reduce like this. C will come here. See now, initially it was here, then C, C, then finally I will bring like this C. So this, as this length is reducing, BC reduces or theta decreases. As theta decreases, I can say as theta, that means decreases, angle decreases. So the length of BC also decreases. BC also decreases, isn't it? This angle, when you reduce this angle, so this was completely like this. You are keep on reducing this angle. When you are reducing, this length will come like this. It was like this and it will be reducing like this. As theta decreases, BC length also decreases. So as theta tends to 0, that means it is going to be 0. So if you further decrease, see like this, it was like this, then reduce it, then reduce it. This angle is reducing here. Once very closer to 0, then when it is very closer to 0, what happens to this length BC? So which implies BC also tends to 0. Am I correct? Are you following me? See, look at this. This is angle theta. You are bending down like this. This theta is reducing to 0. When you are reducing to 0, what is happening to this C? See, this is coming very closer to B, and sometimes when it becomes 0, then C and B coincide. What happens to this AB and AC? What happens to this AC when it is bringing? See, suppose I am bringing like this. What happens to this hypotenuse AC when it becomes 0? This length AC. Length AC will be, so that means AC will become AB. AC and AB becomes same. BC becomes 0. See, when you are making theta 0, observe the diagram very carefully. When you are making theta 0, the length of BC reduces to 0. But hypotenuse will become almost same as, that means when it becomes 0, AC becomes AB. These three you must remember. When theta reduces to 0, BC becomes 0, AC becomes AB. Now, when it is 0, you write this sine 0. Sine 0 degree. Now we have made it 0. You have brought this one to 0. This angle you brought it to 0. What is sine 0? It is opposite side by hypotenuse. Okay. Opposite side here, BC with reference to this angle. When it is 0, what happens to BC? What happens to BC by AC? Actually it is BC by AC. BC becomes 0, AC becomes AB. BC becomes 0, AC becomes AB. 0 divided by AB, it is 0 only. Sin 0 is 0. Similarly, cos 0. Let us see cos 0. Adjacent side by hypotenuse. What is adjacent side here? Adjacent side with, this is angle theta. Adjacent side here AB. AB by hypotenuse here AC. So what happens when it becomes 0? AB will be same as AB only. AB, nothing will happen to AB. When you are bringing this angle closer to 0, AB, nothing will happen to AB. But what happens to AC? When you are bringing AC to 0, this angle, this you are bending like this. What happens to AC? AC will be equal to AB. AC will be equal to AB only. So therefore AB and AB cancels, you will get 1. So what you got? Sin 0 is 0, cos 0 is 1. Tan 0. So tan 0, it is opposite side by adjacent side. Opposite side here BC, adjacent side here AB. So now you tell me what happens to tan 0? BC will reduces to, when you are making 0, BC will be 0. So 0 by AB, it is 0 only. So you got 3 trigonometry ratios. The other ratios can be very easily, you can write cosec